Now I want to look at quadratic functions that are in general form, so how to graph that. So in this case we can't really use the transformations, but I am going to use a formula for this one. So the formula is actually derived by completing the square. So I could actually complete the square, if you're familiar with that process of the function. That would actually result in the function, the quadratic function being in vertex form. And then I could go ahead and then just figure out how far to move left or right and how much to move up and down. But I'm going to actually use the formula instead. So the formula, which comes from completing the square of the vertex, is that the x value is equal to negative b over 2a. So here our b value is 12 and our a value is 3. So if we calculate that, we would have x is equal to negative 12 divided by 2 times a, which is 3. So that gives us negative 12 over 6, which is equal to negative 2. So this is the x value for our vertex. I'm going to write the vertex down here. So we have negative 2, comma. Now we just need to figure out the y value. So for a function, anytime you know one of the values, in this case x is equal to negative 2, you can always plug that in to find the other one. So to find the y value, I'm going to figure out, well, what is f of negative 2? So that would be 3 times negative 2 squared plus 12 times negative 2 plus 5. So here, if we have negative 2 squared, that gives us a positive 4. Times 3, so we get 12 minus 24 plus 5. And when we compute 12 minus 24 plus 5, we get negative 7. And that's the second value for our vertex. So our vertex is negative 2, negative 7, so I'm going to plot that. Right here. And then to finish the graph, I would still want to look at that a value, because sort of the same thing applies whenever it's in vertex form. So if the coefficient of the x squared is positive, it's going to stay in the upward direction, but if it's negative, it would go in the downward direction. So in this case, because that value is positive, it's going to go in the upward direction. And it's going to look something like this. So the vertex is negative 2, negative 7. Once we have that, we can really find all the other pieces as well. So in this case, I'll just kind of squeeze it over here to the right. The axis of symmetry is that x is equal to negative 2. So it's essentially the same x value that you have for the vertex. The domain, it's still quadratic, so the domain is always negative infinity to infinity for any quadratic. And the range in this case, if you look, the smallest y value here is negative 7, and then it just moves up. So it would go negative 7, comma, infinity.